All right, I'm going to try to do this in 7 minutes. All right, for the project, hey, this is the chapter on describing motion. So guess what you're going to have to do for your project? Describe the motion of the wind-up toy. You're going to describe it in words, and you're going to describe it with graphs. So describe motion in words and graphs. You are going to make, first of all, a distance versus time graph, and then you're going to make a speed versus time graph. In order to make these graphs, you have to have a data table of time and distance. And when you write the words describing the motion, there'll be a list of words you have to use. There'll be some vocabulary that has to be, like when you write it, then you underline those words, so I make sure you cover. I want to know what your average speed was. You don't need to write this down because I'm going to give you a rubric kind of a thing. But just to let you know, you're going to have to know your highest instantaneous speed. And you're going to have to, maybe that's it. Maybe that's it. I might have you do lowest instantaneous speed. And there's a couple other things. So you're going to have some vocab that's going to have to be in your description of, you just can't say, well, the toy went for a while and then stopped. You're going to have to give me, you're going to have to describe to me the motion quantitatively, not just qualitatively. Okay. Now then, how do you, it all starts with this table right here. As far as your work in writing it up. This data, the data that goes into this table, the numbers that go into this table, come from the video. I let you do your own videos to start with. Some of you had a good idea of what you wanted to accomplish, and others of you failed terribly. But that's okay. Because it's through that process we learn. I got you. I have a video of your toy in motion. And I took that video straight on top of it with my phone running in a stopwatch mode. All you have to do is go to YouTube, pick your video, play it on YouTube, and if there's, I think this works better on a home computer, you can stop the frame, look at the clock, look at where the toy is at, write down the time, write down the distance. And then I think on a home computer you can push the period key and will advance one frame. And then you look at the clock, you look at how far it moved. Advance to the next frame. You can slow it down, but you're going to be driving yourself crazy. You can move the little slider to get the different ones. I would pick like, all right, I'm going to do this every 0.1 second. So, yeah, so you could go every 0.1 second. But here's the thing. I didn't start the clock the same time I started the guy moving. There was already some time on the clock. So there'd be 16.10. That's okay. Because when you're going to be determining the difference, the delta, the change in time. So you're going to subtract one for the other. This will work. You got a question before I go farther? Yeah. You get to choose, right? You get to choose your reference point. That was one of the first things that we talked about. Your reference point, you're free to choose, but you have to pick it and stick with it. You can't change it. Well, I'm going to pick the front of the car, and then I'm going to pick the back of the car, then I'm going to put the... No, you have to pick with one reference point and stick with it. All right, so say my clock is running 16.2, 16.3, 16.4. It's okay. Just write down this time. So at this frame, maybe I should say it like this. This is frame number 1. Frame number 2, frame number 3, frame number 4. The distance it went, I tried to start them at the starting line. And then it went, at this point in the first frame, it was just getting started, so it hadn't covered any distance. In this frame, it had gone 2 squares. Why did I say squares? Because that's what you see, right? I didn't have a ruler right next to the guy. I had to use the grid. You can convert, though, to distance in centimeters if you knew that 1 square equals 0.7 centimeters. 1 square on my video is 0.7 centimeters. So if I went 2 squares, how many centimeters did I go? 1.4. Okay. Okay. This is going to be a big graph when we all get said and done with this. Okay. So then we go to frame 3 and it's gone 4 squares. And we go to frame 4 and it's gone 6 squares. And we can convert all of these to distance. So 4 times 0.7 is 2.8. And 6 times 0.7 is, what is it? No, I got this wrong. 14 and 14, yeah, 28, 2.8. And then 2 more on top of that is 46. 42, thank you. 4.2, right? What's 0.7 times 6? Somebody get a calculator. 0.7 times 6. 4.2. Okay? So now you have, oh, wait a minute. Now, Mr. A, what about my time here? Well, you still have time in seconds, and you have distance in centimeters, and so now you can make a graph. And so this is 16.10. This is 16.2. 16.3. It's okay to have not 0 in the beginning here, right? And then on your distance in centimeters, so this is time in seconds. And then this is distance in centimeters. And this is 0, say this is 1, this is 2, this is 3, this is 4. And now you can plot this data. So at 16.2, it was 1.4 centimeters. At 16.3, it was 2.8, so on and so forth. So you can use this data table to create this graph. Some of you have already done this. This is part 1.